Okay, as an example problem, let's try to solve problem 33 from chapter 1 of the University of Physics OpenStax textbook. Let's read through the problem. In SI units, speeds are measured in meters per second, but depending on where you live, you probably are more comfortable thinking of speeds in terms of either kilometers per hour or miles per hour. In this problem, you'll see that 1 meter per second is roughly 4 kilometers per hour, or 2 miles per hour, which is handy to use when developing your physical intuition. More precisely, show that A, 1.0 meters per second, is equal to 3.6 kilometers per hour, and B, 1.0 meters per second, is equal to 2.2 miles per hour. Okay, so this is both a nice practice unit conversion problem, but also gives you some helpful things to have in your head, right? When you're solving a physics problem, when you get an answer at the end, it's good to think to yourself, does this answer make sense? Right? That's what we mean by physical intuition. So if you solve a problem and you get something that, a car is traveling at 1,000 miles per hour, chances are you made a mistake somewhere, right? So we want to develop that type of intuition. Okay, but nonetheless, let's start solving this problem. So for part A, we need to convert 1.0 meters per second into kilometers per hour. Right, so first I need to think about how many meters are there in a kilometer. Right, so there's 1,000 meters in a kilometer, or 1 kilometer is equivalent to 10 to the 3 meters. Okay, and I want to take this conversion factor and turn it into a ratio. If I divide both sides of this conversion factor by 10 to the 3 meters, I have 1 kilometer divided by 10 to the 3 meters is equal to 10 to the 3 meters over 10 to the 3 meters, right? Or equal to 1, right? So this ratio is equal to 1, meaning I can multiply this ratio by any other measurement, and I'm not changing the measurement, I'm just converting from one type of unit to a different type of unit. So I can multiply 1.0 meters per second by this ratio, 1 kilometer divided by 10 to the 3 meters, and we can see that when I do that, my meters cancel, and I've now basically converted from meters per second to kilometers per second. Okay, so I'm part of the way to my solution. Now I need to convert those seconds to hours. Again, you could look up the conversion factor, but you probably know how many seconds there are in a minute and how many minutes there are in an hour, so let's just use that. Right? There are 60 seconds in 1 minute, so I can cancel out those seconds, and now I have a measurement in kilometers per minute, and now I know there are 60 minutes in 1 hour, so my minutes cancel out, and now if I multiply this all out, I have something in what I'm looking for, right? Kilometers per hour, right? That's what I'm looking for in part A. So okay, I multiply that out, and I get 3.6 kilometers per hour. Okay, exactly what they were looking for. So great. On to part B. This time we are again going to convert 1.0 meters per second. But this time we are going to convert into miles per hour. To do this, we are actually going to have to look up how many meters there are in a mile because they don't tell us that. So we can look up that conversion factor, and it turns out there is exactly 1,609.344 meters in 1 mile. Right, so that's my conversion factor. So if I want to start off by converting meters per second to miles per second, I can use this conversion factor, again turn it into a ratio, and I want to have meters in my denominator so that my meters cancel out. Right, so 1,609.344 meters is equivalent to 1 mile. So that ratio is going to convert my meters per second into miles per second. And now I need to do again the same thing I did earlier, convert my seconds into minutes and my minutes into hours. So again, I have 60 seconds is equivalent to 1 minute, and 60 minutes is equivalent to 1 hour. So when I do this, my seconds cancel out, my minutes cancel out, and I end up with what I'm looking for, something in miles per hour. Okay, so when I multiply out all of these numbers here, I get my answer. There is 2.2 36936 something 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 miles per hour. Okay, so we get a lot of digits. Okay, so that may be the case that 1 meter per second is equivalent to this many miles per hour, but they didn't give us a number with infinite precision to start with. They gave us a number with 2 sig figs, right? They gave us, let me see here, they gave us this number, all right, 1.0 meters per second. There's only 2 sig figs. This is a measurement that has been made that is only so precise, right? So I need to report my answer once I convert my units to a different type of units. I need to maintain that precision, right? So I need to report my answer also with only 2 sig figs, right? So to convert this into 2 sig figs, this just becomes 2.2 miles per hour. Okay, so again, that is what they were looking for in part B. Okay, and just as a last note, just take a quick look at our conversion factor here. On the left side, we have 1609.344 meters is equal to 1 mile. So it may look like we only have 1 sig fig in that conversion factor, but when I told you that conversion factor, I told you this is exactly true, meaning this is equivalent to saying there's 1.00000 miles is equal to that many meters, or any number of zeros. Right? It's exactly true. So for a unit conversion factor like this, we don't use that when thinking about sig figs. We only are going to use what they give us on the problem, the actual measurement. Right? So that's it for this problem.